Hello, worldly crazy people out there. My name is Michael. I like wizards and dragons and making games, and welcome back to making games in GameMaker in 3D. Let's see. So recently, in the last couple of videos, I've started to do things with spells, push spells. We can cast push spells on objects and make them roll. And today, I'm going to be doing a little bit more of that, I think. And we are going to be implementing a few more things that you can do with a push spell. This is probably going to be the last video I do with regards to that spell before moving on to something else, but hopefully between blocks, rolling objects like barrels and boulders, and also like flippable switches, toggle switches, push buttons, that kind of thing that you can activate with push spells, we should be able to do a number of fun things in the game with, what are even words? Magic systems and that kind of thing. Before I start, however, I kicked myself a little bit when I was editing the last video because I rigged up this weird system regarding like offset matrices and stuff for transforming objects that like might roll but might need to stay on the ground and that kind of thing. And yeah, when I was looking at that code a little while later, I realized that instead of having to rig up this weird system to transform like a boulder or something like that so that it stays above the ground, I could, where's the boulder? So these things are spherical objects and they have an origin at the center, at the world origin, right? And I was like applying a translation of 16 in the air to push them above the ground. And as it turns out, that's a little bit not necessary, because what I could actually do, and it would make my life and everybody else's life who's reading this just so much simpler. This is... Alright, where is this defined originally? Alright. So in the 3D object draw, I could just like remove everything with regards to the offset matrix, and I could just like place the objects that high in the air to begin with, and we could just save so much time. Alright. So I think that's going to be the end of that. And boulders and barrels will now be swimming in the ground, but I could just give them, you know, an actual translation of just like 16 when I spawn them or place them in the level. And alright, so that was a little bit silly. Let's see, where are we spawning these? Down at the bottom, I think, is where I spawn my test objects, so I could just give those 16. And, let's see, that's going to be pretty much the same without any of the weird nonsense. Alright, so rolling looks good. And, again, we just don't have any weird nonsense. I am going to need to find this GitHub thing. And now we can move on to what I'm actually going to do today. So I want to do flippable toggle switches and push buttons today, and you can activate those by casting push spells on them. So that brings us to what I'd actually like to do today. So today I'd like to implement push buttons, and here's a little description of what they might do. And also toggle switches, and here's a little description of what those might do. You can cast spells on them, and then when they trigger, they'll do a thing. And flip switches, you can cast spells on them, and they will revert between the inactive and activated states. And when the state changes, they'll do a thing. I have implemented, or I should say, I've designed some basic like button-shaped things in and I've added them to the game's data files. So this is going to be a button. It's composed of two parts. There's the base and there's the button part. And this toggle switch, two parts, the base and the lever thing. And I will leave that open for now just in case I need to keep making any changes. Let's see. Gameplay stuff, 3D objects. If I were to, let's say, duplicate block, and we could call this toggle switch. How about we could design some states for this, I'm going to design some states that are, let's see, I'll just create them and I won't fill them in with any code yet. But we're going to have idle. No, we're not. We're going to have inactive. We're going to have activating. We're going to have active. And we're going to have deactivating. It's going to default to the inactive state. Let's see, on spell hit. We're going to check our spell response. Alright, that just, in the blocks, this is what causes us to go into the moving state. Alright, let me get rid of that too for the time being. Target, that can be set to undefined. That can be erased rather because we're not going to be exactly just moving to a place. I will define the switch angle. So the switch angle is going to be a rotation about the z-axis that's applied to the lever part of the switch. And when it's in the active state, it will transition to, I think, about 60 degrees should do, to indicate that it's on. And I'm going to work on implementing that in a minute, but first I will commit the toggle switch states. It would probably be a good idea to, let's say, instantiate one of these toggle switches. Set mesh, self.meshes. It's just called switch, right? Is that legal? Can I do that? Is that going to be a problem because your like switch is a keyword? If I do that, will this just break? Will GameMaker even let me do that? No, it won't. Alright, I'm going to have to rename that. Let's call it toggle switch. If only it let you do that, right? Oh, you know what I also need to do? I need to define collision, like collision shapes for these. And just like that, each of these objects have both collision for the player that the player can collide against them with, and also collision that's just a little bit bigger, and so that you can target them with spells a little bit more easily. So, if I run the game now, we should have a switch on the ground. And I'm gonna have to define an update for these anyway. Alright. As long as one of these no state states has a method called update, then they'll automatically be transplanted onto all of them, even if only one of them has it defined. So we can, oh, you've also been spawned in the air, have you? That's fine. We can run into you, we can target you. Nothing's gonna happen when I cast a spell at you. But let's move you back to the ground. Let's see, like your basic DNA is there. So when we cast a spell on you, I'm going to also give each of these a method that's on spell. How about? And when it comes to the inactive state. When you're on spell, that's only going to be a matter of self.state.change to the activating state. I have to make sure to spell that correctly. And, spell that correctly. When you're active, we're going to do the reverse. We're going to send you to the deactivating state. And when you're in the activating and deactivating state, we're going to have an update method, which I did implement approach for numbers, right? It looks like I did. We can have the switch angle approach. Let's say it's from its current value to its target value, which might be 60 degrees or so, and its amount, which is going to be, let's say, 60 degrees per second times delta time, and then if come on. It's getting to that time of year when, like, everything is colder than necessary. Like, it's late September, and my fingers are cold, and, like, you know, because everything negatively affects my typing accuracy. Cold fingers don't exactly help either. So, we can do the same thing in the deactivating state, but we're going to go in the opposite direction. If switch angle equals 0, we can set our state equal to inactive. The on spell for the active state. Okay, we already did that. Is we're going to send it to deactivating, and then when you get hit by a push spell, then you can just execute whatever the on spell method of the current state is. So that's half the work. That's going to be half the work for toggle switches. The other half is going to involve drawing, and I feel like, so by default we're going to do this, right? And this is going to set our transform however is necessary. It's going to call the render method on our assigned mesh, which is going to by default render every submesh. So however many that happens to be. The toggle switch has 2 for the base and the lever. And then it's going to reset the identity matrix. And I feel like that's usually fine, but I'm going to want to override that for certain things. How about, is it time to give every object a .render method that's just this, and then you can override that without messing with all the other stuff like this debug drawer over here? Or should I just, is it not worth doing that for objects like this, now that I'm mostly done with collision, and should I just take our draw event and override the draw event? I feel like that would be easier. It doesn't feel like there's any, let's say, override event. Like, if I had to debug the collision shapes for one of these objects, I could, but I think that might be a little bit object-oriented, like, overkill for the moment. So we can draw the base, and then when we're done with that, we can draw the lever. And drawing the lever is going to be the same. That's going to be, we can hardcode that, at least for now, to submesh index 1. When you draw the lever, I'm going to start with a rotation, which is going to be matrix build, no transform. The rotation is going to be self dot, what was it, switch angle around the z-axis, scale of 1, like that. We can matrix multiply transform into that lever rotation, not level rotation, and then we can render the lever. And I can run the game now. I should be able to cast a push spell on our friend Switch, and okay, that's cool. If I stand back, can we really see it in motion? We can. All right, that'll come, I'm sure, with an appropriate sound effect, like a creaking metal sound effect, and that'll be satisfying, I'm sure. I can get rid of that extraneous matrix set because I don't need that. Now, let's see. I can call it there, I think, for the states. We can say that we've implemented those. Lastly, there's just going to be the matter of making something happen when you land in the active and the deactive state and the inactive state. So if I implement 2 methods for on activation and on deactivation, in the enter method for this, we can call the on activation. We can also call the on deactivation for the inactive state. When you initialize a snow state, there's an optional parameter for execute the enter method, and that defaults to true. So I think for this I'm going to want to default to false if you don't want whatever happens when you deactivate a switch to happen like every time you load a level and create one of these switches. So let's throw an exclamation mark in there to make it look, you know, more exciting and what have you. When we've got this, I didn't ask you to climb on that. When we've got this, if you activate a switch, we can see that method. These methods can, instead of just showing a message box on screen, they can do things like open doors or, you know, spawn an enemy or something of that nature. And I think that's going to be that. However, I would like to unhardcode these. I can say, let's say the target angle for the activation is 60 degrees. We can say movement speed is also 60 degrees per second. If you want it to be faster, you can make it maybe 90 degrees per second. And we can use those values. Like this. And copy those changes over here. The only difference being that the target angle is going to be 0. And I think that is it for toggle switches. Alright. Alright, so where are we going after this? So I think I can check off the flippable switch. And we can say that that's done. Buttons next. Buttons should be a little bit easier because they only have one state, but otherwise they should be pretty similar. They should be pretty similar to what we've already got for these switches here. Let me instantiate a let's say a push button there. That was just called a button. Should I call this push button? Nah, that's fine. And to make these work, let me first define some of these states. So we're gonna have. Actually, you know what? Should I like keep the same name so we can have inactive when it's like primed? We can have activating. We can have active, which is when it like it reaches its final state, and then we can have deactivating for when it goes back. I actually kind of like that idea. Actually, let me start by saying switch angle. This can be button offset equals 0. So that's going to be some distance. That's going to be the distance that it's like that this like nosy thingy is like pushed into the plate. The logic is overall going to be very similar, but instead of dealing with angles and approaching angles, we can say target offset can be like, oh, I don't know, like -4 or something like that. We can say the button offset is going to be button offset approach that. The movement speed can be like, let's call it 4 again. We can everywhere where the switch angle is defined, we can just like we can update that target offset and that sort of thing. So that's going to be what happens, the update when we go into our active state. Deactive is going to be the same thing, but we're going to have a target offset of 0. And we're going to go into our inactive state. When you cast a spell, so on spell when we're in the inactive state, it's going to change our state to activating. These will not respond when they are in the press state. They will not respond to a spell. They will only respond to a spell when they are, you know, I guess maybe primed would be a better word than inactive. I'll go with that, I guess, because that makes it sound like inactive makes it sound like it's just not going to respond. And that's going to be our states. And as for the drawing of this, instead of taking the angle and applying a rotation to the angle, we are going to take that button offset on the y-axis. So it's going to go up and down along the y-axis. And that should be that. These are going to be very similar objects, so if the button's on fire. Alright, that was fine for bigger objects like barrels or whatever, but let's make the button not be on fire. Let's move the button out some distance. About a tile or so away from the fire. Or I could just, like, get rid of the fire. Alright, so... Indeed, when I cast my push spell on that, the button went down. I think I can actually tweak that value a little bit. So our target offset is going to be, like, let's say... Would 6 bury it in the plate? So if I... Okay, no, that's fine. And also, that's a little slow. We can maybe speed up the movement speed a little bit. So it'll take a little bit less than a second to fully impress. And... Alright, and we can't target it again. Well, we can target it, but we can't make it do anything again. Which is fine. So, states, visuals... we can have a pushable button. I am considering, though, the difference between having a button which can only be pushed once and having a button which, like, it presses and then you can, like, keep pressing it infinitely. And to handle that, let me create a little variable definition that's going to be, like, infinite use. And we can set that to a Boolean, and I guess I'll initialize that to true. We'll say if a button is infinite use. I did not spell infinite right. Then as soon as we hit our active state, we can call our activation method, and we can go to the next. We can, like, change course and go backwards. We can change to the deactivating state. And I also realized that having the on deactivation method doesn't make any sense for a button, because it's supposed to be like a single effect and not going back and forth. So we can get rid of that. And now, this button will default to infinite use. And we'll be able to press it multiple times, so it'll go down and then back up. I still feel like maybe that's a little slow. We should speed up its movement speed a bit. Say it takes a half a second to have the full effect. To fully transition, rather. Alright, I think that's fine. You can, like, mount that on a wall. Great. That is going to be a button that can be either single use or infinite use. And I've been recording for about half an hour, and I think that's going to be enough for this video. We got done what I wanted to get done today. Next time, we're going to be doing unlocking spells. So the premier magical spell that you might find in a game like this. We're going to have... I saw it. It's this one, the unlockable spell. That's going to be something that we'll do first thing tomorrow, or not tomorrow, but whenever the next time I do this is. Treasure chests. So I also added a separate, like, models for the top, bottom, and lock on a treasure chest. And we'll be doing something very similar to these push buttons here for treasure chests. And was there another one? I think there were doors. Doors. All right, so we can do doors. And there's also, like, in the Potter games, there's a ton of other, like, object types that you can cast Alhamura on besides doors and treasure chests. You can, like, funny, suspiciously fake walls, or, you know, that kind of thing. But I'll start with this. Other similar objects should be, like, they should take, like, 5 minutes, all of 5 minutes to implement once I've got this out of the way. Should be pretty fun. So, my name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository down in the video description. I swear that Codex's target velocity is just, like, broken, because it doesn't seem to know how much we're doing every week. Like, if I target 5 points of effort per week, it's pretty consistently spitting out. The estimated date to 0 is, like, May 2025, which is reasonable. Oh, is it basing it on this? Is it doing, like, some kind of regression from this? And I don't know how it's coming up with this number, but it's... Like, it doesn't seem to realize that I've been knocking things off every week. just not every day. Anyway. Where was I? If you want the code for this, look for the GitHub repository down in the video description. I try to post about 2 game dev videos a week. One let's make a game like this, one tutorial. I like doing weird 3D things in GameMaker, so if you're interested in any of that, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. I hope you all enjoyed that, and I will see you all later. Special thanks to Army Armbuster, DJ Gibbles, Edward Holt, GameMaker, Gamer Player, John Luigi Celentano, Manta Ray, Syndra Larson, Squarecrow, Vitro V, and Zenjamin for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.